Hello students, today in this session I will discuss about standard form and comparison of the rational numbers, and after this session you must learn the standard form and how to compare two given rational number. For a standard form of a rational number, you have to just keep three things in the mind. First one, that its denominator must be positive. Second one, you must know that it has no common factor. Its numerator and denominator has no common factor other than 1. And third one, that you have to just keep in mind that its numerator may positive, negative or 0. Let's check by examples. Case first, denominator cannot be negative. For example, 4 upon minus 3. This is not called a standard form. Or 2 upon minus 7. It is not the standard form because denominator in this case, denominator 3 is negative, 7 is negative in this case. So first thing you have to just keep in mind that denominator cannot be negative. Second one, that you have to just keep in mind that it has no numerator and denominator cannot have a common factor other than 1. My dear one, you have to just see that 2 upon 4. You know that 2 upon 4, it has common factor other than 1 because you can just find out its SCF. You know that when you find out SCF of 2 and 4, then its SCF is 2. So regarding lowest form, you must keep in the mind that it has no common factor other than 1 means its SCF should be 1. So you have to just find out SCF of numerator and denominator, and if SCF is 1, then it is considered as lowest form, and this is why standard form is also known as lowest form, or it is sometimes it has written in the book that reduced form. Lowest form or reduced form, it is due to that when you have find out SCF of numerator and denominator, then its result is 1. And also you have read in a previous standard that such numbers are also called co-primes. So simply you can just see that if numerator and denominator are co-primes, then it can be considered as a standard form. So two conditions you have learned. First, denominator cannot be negative. Second, numerator and denominator of rational number must be co-primes, means it must have SCF 1. It cannot have common factor other than 1. And third case is its numerator may 0, positive or negative. Any integers may possible. For example, 0 upon 2. It is also the standard form, or minus 3 upon 5. It is possible because numerator is negative, no problem. Or 2 upon 7. It is also a type of rational number, and it is also in standard form. So you have to just keep in mind that these three things. Numerator may 0, negative or positive, but denominator cannot be negative. In place of minus 3 upon 5, if you write 3 upon minus 5, then it is not called standard form. It is rational, no doubt. Rational may positive or negative. Whatever, this is not in standard form. Now, it has been asked in the question that when any number is not in standard form, then how can you convert into standard form in the case of rational? 3 upon minus 5 is not in standard form. You have to simply multiply by minus 1 to its numerator and to its denominator. The result becomes minus 3 upon 5, and now this has converted into standard form. So you can multiply minus 1 to the numerator and denominator to change the number in any form, usual form to standard form. Regarding the comparison of the rational numbers, you must keep the points in the mind, five different points. I have written on the board the list. First one is positive rational number must be greater than 0. Positive. And you also know that on the number line, positive rationals are located in the right side of 0. It is due to that every number which are located in the right side of any other number must be the greater number. So positive rationals are greater than 0. Second, you have to just keep in mind that negative rationals are less than 0. It can be shown by example. For the 1 upon 2, you know that it is the positive rationals, because you have learned in the previous video or session that any rational whose sign of the numerator and denominator are the same sign, means positive or negative, then consider as positive rationals. You can just see that 1 is positive, 2 is positive, both having the same sign, so it is the positive rationals, and these positive rationals must be greater than 0. Regarding negative rationals, minus 1 upon 3 negative located in the left side of 0. It is due to that any numbers that you know very well that any numbers which is located in the left side of 0 must be less than the 0, and all negative rationals are less than 0. And negative rationals, you know very well that the rational whose sign of the numerator and the denominator are different. If numerator is negative, then denominator is positive. If numerator is positive, then denominator is negative. If numerator and denominator are having the different sign, then it is known as negative rationals, and all negative rationals must be less than 0. Sometimes a student get confused when both having the negative sign, minus 3 upon minus 2. My dear, this is a positive rationals, because both having the same sign, so it must be greater than 0. So you have understand first and second case. Regarding the third case, every positive rational numbers are greater than the negative rationals, and you know that positive rationals are the right side of negative rationals, so must be greater, and it can easily be understood by drawing the number lines. And for example, you must know 1 upon 2 is greater than minus 1 upon 2. So every positive rationals must be greater than the negative rationals. Quite interesting in the case of 4 and 5. And you have already used this rule in previous class. In 7th standard, in 6th standard, and to compare the fractions. Whatever its rule has been just discussed in this standard, that if two rationals, you can just pay attention that two rationals are 4 upon 5 and 3 upon 5. And what is the common? Common is its denominator. You can just see that denominators are equal in both the cases. If two rationals having the equal denominators, then you have to compare its numerator. If you compare 4 and 3, which one is greater? You know very well that 4 is greater than 3. So there is a rule that when two or more rationals having equal denominators, then the rational number is considered as larger or greater decimals whose numerator is greater. In this case, 5 denominators are equal. Since 4 upon 5 in this decimals, 4 is larger to the 3. So 4 upon 5 is greater than 3 upon 5. It can be understood by one more example. 7 upon 13 and 8 upon 13. Now you have to do which one is greater. At first you have compare its denominator. Denominator are equals. Then what is to do? If denominators are equal, then you have to compare its numerator. 7 upon 13 having 7 as numerator, 8 upon 13 having 8 as numerator. So you have to compare. 8 is greater than 7. The rational which is greater, whose numerator is greater. That means 8 upon 13 is greater than 7 upon 13 because 8 is greater as compared to 7. In case 5, it is just opposite. Now denominators are different and numerators are same. In this case, it is the rule that when numerator is equal and denominators are different, then the decimal number is considered as greater decimal whose denominator is smaller. Smaller. You have to just pay attention. In this case, you can just see that 7 upon 5 and 7 upon 3. Numerators are equal. Numerator, you can just see that 7 and 7 and both are equal. Then you have to just compare its denominator. Which one is larger? 5 is larger than 3. Or you can just say that 3 is less than 5. The rational which is considered as greater, whose denominator is smaller. Since 3 is smaller as compared to 5, so 7 upon 3 is larger than 7 upon 5. One more example. 2 upon 9 and 5 upon 9. Actually 2 upon 11, because I am taking the example of whose numerator is same. You can just see that 2 and 2 numerator is equal in this case. Then you have to compare its denominator 9 and 11. Which one is greater? You know that 11 is greater than 9. 9 is here smaller. So by the rule it has been given that when numerator is same, then whose denominator is smaller, whose rationals. Actually 2 upon 9, this rational having a lesser denominator, so it must be larger as compared to 2 upon 11. The last one has been given that if A upon B is greater than 7 upon A upon B is greater than C upon D. My dear, you can just see that. My dear, you can just see that A upon B is greater than C upon D. Then if you convert into the positive to negative, then the greater decimal in positive is smaller as compared to a smaller one. How can? You can just see that 1 upon 2 and 1 upon 3. Which one is greater? And you know that numerator is equal, so denominator is less in case of 2. So 1 upon 2 is greater than 1 upon 3. By rule 5th, you can just apply that. 1 upon 2 is greater than 1 upon 3. If the same decimals, but if you have taken the negative one, 1 upon 2 and minus 1 upon 3. Which one is greater? You must know that no, minus 1 upon 2 is smaller by the rule 6. And which one is greater? Minus 1 upon 3. It is due to that you know very well that minus 4 and minus 5. Which one is greater? Minus 4 is greater. It is also applicable in the case of integers. 5 is greater than 4, but minus 5 is smaller as compared to minus 4. When the greater positive convert into negative, then it must be smaller to the smaller positive which convert into negative one. Hope you have to utilize this session, and on this basis you can just solve the question that is given in your books. So this is the homework for you. You have to just solve the questions, and if you have any problem, then you have to wait for the next video. Thank you very much.